Hello everyone, I am Sindhu and today we shall be looking at how a blockchain works in the simplest form possible through a visual demonstration. Now let's get to the page. Yeah, so this is how it's supposed to look. Yeah, so this is the page where we look at something called SHA-256 hash. So, as we come across blockchain, we will get to the topic of hashing algorithms. We all know that blockchains are cryptographically signed. So, what is the cryptographic signature, anyways? It is basically what we see here, which is called the hash. So, for every data that you input into the system, you shall receive a different hash. But what we must also consider is the fact that no matter how long or short the data you input is, the hash will always be a fixed set of numbers. I mean, the combinations are all different. Every output is different depending upon the data. But the observable fact is that all of these will have the same number of characteristics. So let me type in my own name, Sindhu, for example. You see how the hash changes? Or if I change it to Bitcoin, again, the hash changes. So we notice that the hash is dependent on the data for it to be changed. So this is about the SHA-256 hash. Remember hash as a digital signature, and SHA-256 is a hashing algorithm that is used widely by most blockchains. Moving on to a block. A block is a more comprehensive form of what we saw earlier, where there is something called a block number, a nonce, then data, and the hash. Block number is used in order to sequentially arrange the blocks of a blockchain. So this signifies or indicates that this block is the first block of this blockchain. And you will notice that as I type in some data, the hash changes and there is a red screen that's popping up. And this is because this data has not been hashed yet, or this data has not been part of any of the blocks and it has not been hashed yet. Hence, it's not part of the blockchain. So if I'm just gonna enter in my name and then let's say I mine it, then now this has become a part of the blockchain, right? Because now it has been added because it's been mined. Now, moving forward with what a blockchain looks like. A blockchain is a group of blocks which are arranged in a sequential order. And all of these blockchains are connected. All of these blocks in the blockchain are connected to each other through the previous hash. So you might notice how there is something called the previous hash before and then beneath which is the hash. This previous hash of the first block is just zeros because there is no previous hash before the previous block before the first block, right? So since this is the first one, there is no previous hash. However, the second block has a previous hash, which is the hash of the first block. So the previous hash is what connects the current block with the previous block, thus forming a chain of blockchains. And you will notice that one change in this nonce will affect all the blocks that follow later. And that is because the hashes are respectively changed, right? Because now that the nonce has been changed, the hashes have been changed. And once the hash of one block is changed, all of the hashes following it will change as well, thus changing the entire blockchain system. So that is how the blockchain works. And because the blockchain is of an immutable nature, um, this does not really happen, or it cannot be possible for you to change an already mined block. So this phenomenon is not possible. Moving forward to distributed blockchains. So blockchain is distributed along different nodes of a network, right? So now we have peer A, then there's peer B, then there's peer C. And notice how all of these have the same hashes for the blocks of the same number, like the block 2 and block 1, the block, I mean, all the blocks are having the same hashes, and that is because throughout the distributed blockchain, the numbers or the throughout the distributed blockchain, the truth remains the same. There is one universal truth for all the blockchains. That is what binds them. So now let's say I change one number of this of the peer A blockchain node, and you will notice that this one is definitely inaccurate, that all of them is wrong, it has not been signed yet, it has not been added. But you will also notice that peer B and peer C remain unbothered by the change. And that is because you cannot change the blockchain because of its immutable nature. And also, the information that has been validated has been happening because of all the nodes being in agreement with each other. And the change in one blockchain cannot result in the change of the other blockchains because all the blockchains are supposed to have the same information. And this basically signifies, this mistake or this inaccuracy signifies that this blockchain has some is inaccurate. And this is not a normal phenomenon because it is impossible or close to impossible to change this immutable ledger. Moving forward to tokens. So in this part, we will be looking at how under the transactions part, which serves as a very important data component, showing the amount that is being sent and received by the different parties. So you will notice that if I change one thing, everything differs. So that basically showcases the immutable nature again of the blockchain system. Moving forward with Coinbase, Coinbase transactions are the most important transactions. They are like the underlying transactions that form the basis of the future transactions. So in this case, we'll notice that in block one, $100 are received by Mr. Anders. And in the next block, you will notice that this $100 is being sent over to for different people, and you will notice that these people in turn send it to other people in the third block. And this shows the verifiability of a blockchain. That is, you can notice for the changes or you can notice the history and know what is actually happening in the blockchain because it cannot be changed and it provides a thorough history of the transactions that have already occurred. So that is how a Coinbase transaction works. And yeah, so in the simplest way possible, we have now clearly observed how a blockchain works in its simplest forms. So I hope you understand it. Hope I was clear. Thank you for listening.